Let's try to understand what is a finite state machine. Finite state machine is a mathematical model of computation that consists of the following features. It consists of the finite number of states, and between each state there are transitions. In order to moving from one state to another, it uses rules based on the input symbols. As I said in the introduction video, finite state machines can recognize regular languages. That means if you have a language, you can prove that it is a regular language by drawing its corresponding finite state machine. Let me draw a simple finite state machine to understand it better. Assume that we have two states, Q1 and Q2, okay? Q1 and Q2. In order to identify the starting state, we put an arrow in front of it. And in order to understand that Q2 or some other state is a final state, we draw a double circuit. So this is a final state. The transition basically means the arrows between each state, which are actually the functions of inputs. So based on the given input, the transition function allows you to go from one state to another. Essentially, there are two kinds of finite state machines. Let me write it. DFA and NFA. DFA is a finite state machine where each state has exactly one transition for each possible input symbol. Let's write it. Has exactly one transition for each possible input. On the other hand, an NFA is a finite state machine where each state can have 0, 1 or multiple transitions for each possible input symbol. Let's write it 0 or more. 0, 1 or more. Or more transitions. For each possible input. Also, NFA includes transitions without any input. That means epsilon transitions. So, NFA allows to use epsilon transitions. By the way, for the time being, it is very normal for you to not understand these terms. We will see each of them in deeper in the following lectures. These are just the basic terminologies that you should be familiar with. Okay. Another thing that you should know, and it is actually the biggest difference between DFA and NFA, is the determinism. Being deterministic allows two things. First, unique transitions. Unique transitions means that for any given state and input symbol, there is exactly one defined next state. This means that the transition function maps each state and input pair to a single, specific next state. And secondly, it allows predictability. The behavior of a deterministic system is entirely predictable because the same input will always result in the same state transitions and output. Let's draw an example. Let's say we have a state Q0, Q1, and Q2. If it is a deterministic, Then for each input, let's say for input 0, okay, it should exactly go to one specific state. So for 0, it should go to Q1, let's say. And same for Q1, it should go to one specific state. But if it is a non-deterministic, then when the input is 0, let's say, it can go more than one state. So it can stay in Q0. At the same time, it can go also to Q1. And it can also go to Q2 as well. I mean, of course, it depends on your mission, but it is allowed when it is non-deterministic. Also, in NFA, the empty string represented by epsilon can be used in transitions as well. So when it is NFA, we can use empty string. That means it allows the automaton to move from one state to another without consuming any input symbol. However, in DFA, every transition must be based on an actual input symbol from the alphabet, and epsilon transitions are not allowed. Let's write it. Epsilon transitions are not allowed in DFA. Okay. And before finishing, I want to write some important things for DFA and NFA. First, both DFA and NFA recognize the same set of regular languages. So we can say DFA and NFA recognize same set of regular languages. And also, any NFA can be converted to an equivalent DFA. So NFA to DFA conversion is possible. And we will see that in the future videos. I think it's enough for today's lecture. We have learned what is a finite state machine, what are NFA and DFA, what is the meaning of being deterministic, and what are the key differences between NFA and DFA. In the next lecture, we will delve into DFAs. I hope that you have enjoyed watching this video. See you in the next lecture.